Hello, YouTube. This is Luis. We are once again back for CS 4540. And this week, week six, we will be looking at LLMs, but specifically the process for how it learns its reinforcement learning. This week's topic will mainly cover just one video, that being deep dive into LLMs like ChatGPT by Andre Karpathy. And we're only looking at one video mainly because of the length of it. So this video spans about 3.5 hours, and essentially covers the entire process. So we'll just be looking at this video, dissecting each individual process that it describes, and kind of going from there. So let's start off with just a quick overview for what we will be discussing. So we start off with kind of looking at what we've been discussing before, which is breaking up, uh, text into tokens. And what this essentially states is that when a user inputs a query into something like an LLM, this input is broken up into tokens, right? And each token corresponds with maybe an individual word or a chunk of a word. But essentially, each token has a value, and this value corresponds with some predefined value. And this is any combination of characters that is tied to some predefined vocabulary for the AI model, right? And how these tokens are processed, we will be looking at more in the following slides. So let's go into those. So we first look at pre-training. And what is pre-training exactly? Well, it's essentially what we've been talking about, uh, you know, for these past few weeks, which is just training the model based on information gathered about a particular topic or a particular query. So we can imagine this as kind of the training sets that the model is trained on, right? The information that's gathered from articles, videos, text files that are directly given to the AI model to train off of. Uh, and this is unfiltered information. And essentially, this is just the information that is given to the AI to build its parameters for future processes that it may come into contact with. And then we get into post training. And post training is essentially using this information and kind of using it to formulate some kind of response to a given query, right? And so, kind of building off of tokens, in addition to the tokens made up by the query made by the user, additional tokens, hidden tokens, are uh, put alongside those. And those essentially guide the AI into distinguishing where a user query starts and where its response should start. So in the screenshot provided, we see that we have a user start block, right? And so this essentially states where the user's query starts, what is 2 plus 2. And then we have the end block for this user query. And then we start with the AI assistance response. We start here, and then this is produced as the result 2 plus 2 equals 4. We end that, and then we have another start block for the user, which is a follow-up question. What if it was times? And then we end that user query, and then we start with another response by the AI. And so essentially what we're looking at is our blocks that are hidden in the tokens that are processed by the AI to kind of tell it what to do, uh, what information to pass off as user data, and what information to give it as a response. And so we kind of see what other resources are available to the AI when formulating these responses. So the video talks about two key uh, tools, which are the use of code and the use of a web search function when formulating responses. So in terms of code, we can think about this as kind of like the scratch paper or the thinking process of an AI tool or of an AI algorithm. So when a common query is given to the AI model, uh, it doesn't typically think through these responses. It kind of just gives answers based on the predetermined parameters in its code. But when using an actual code tool in its responses, it's able to process even further, right? And so the video gives us a clear example of this when giving it something like basic arithmetic or something like counting the amount of characters in an input, right? And so without the code, it's kind of going off of what it's been trained to do, and it won't get as specific as counting the individual characters or thinking of things in a more detailed manner. It'll give you a more broad uh, answer based on what it's been trained on. But code will allow it to use tools that weren't previously at its disposal. So the video gives an example of a string of various periods or decimal points, and it asks the computer to give the amount of periods, the amount of decimals that are being inputted. Regularly, the AI model will not be able to give you the exact number. It'll give you a rough estimate, but it won't be able to give you the exact amount. Meanwhile, if you tell it to use code, it can use it can copy and paste the string of decimal points, and through code able to give you or is able to give you a more precise quantity. And so we now look at the second tool that is being mentioned, which is a web search. So I don't think it's shown here in this screenshot, but kind of similar to the last view, where it kind of distinguishes where a start and an end block for a user query is. An additional token is put into the string of tokens, which essentially prompts the computer to initialize a web search of a given query. So this question that is being asked of it is copied and pasted into something like Google or Bing search. And it filters through all the given materials, gathering the necessary information, and then producing a, an adequate answer. Uh, but the video also goes into detail about some of the problems that can arise from something like a web search or not specifying enough what it should be looking for in a potential answer. Uh, and the example given is, if you're asking it something that it's never seen before, like what are you, right? Who made you? And if it's not given a clear answer, it looks through the resources on the internet or what it looks for, um, and kind of uses information that uh, isn't specified to itself as general information, even if it's not pertaining to the situation. And so, a model that's not trained on OpenAI uh, is asked what it is, but it's not trained to answer that, and so it'll look through uh, various resources, sees that every resource gives the answer that it's made through OpenAI. It returns to the user that it is also made through OpenAI, even when it's not. And so it takes on this false identity, this false sense of self, this hallucination, um, when giving answers. And so it's important to kind of know how to pose a question to an AI or how to train an AI so that it doesn't fall into one of these hallucinations. And the final step for this process is reinforcement learning. And so the video explains this as kind of taking uh, prompts and formulating practice responses. And so, how this AI model learns is that with any given prompt, it produces several responses. And through each response, a human, or as we'll talk about later, a reinforcement learning uh, made from human feedback will be able to tell the model what answers are preferable, right? And so this is just for one prompt. So thousands of prompts are processed at the same time, each producing thousands of preliminary solutions. And the basic idea is that you look at each response and kind of tell the AI which you're looking uh, for a given prompt. And when you give it enough of these instances where no, this answer isn't correct or this answer is correct, keep producing answers that are similar to this, it'll be able to learn much better. Um, but this model obviously is not uh, the most optimal because when you're looking at thousands of, if not hundreds of thousands of responses, you can't have a human or a team of humans look through each response and give adequate feedback because that's just not possible. Um, and as such, there's something called reinforcement learning from human feedback, which is essentially training a model to kind of think in the way a human would think when answering these prompts. Uh, and so this can be made through a singular example, such as rating, an answer to a basic problem like 2 plus 2. If a response is uh, constantly given positive human feedback, the AI kind of picks up on this and learns to, uh, respond well to itself if it looks similar enough. And so this is essentially the same process that we've been talking about before, where an AI model kind of builds uh, the parameters for its algorithm based on a series of inputs. Um, and this process is replicated in this human feedback uh, process. Um, and yeah, that should realistically wrap up this discussion. Um, just one final message is that this is uh, kind of branching off of what we've been talking about in previous weeks, which is just building the parameters for an AI model and how it responds. But this kind of goes more into detail about once this is done, once answers are being produced through this pre-training stage, how can we as humans, as developers, kind of build on that, tell the AI what answers are proper, are ideal, and how does the AI learn from those? And so we see that various tools can be used, such as the use of code or searching up a query on the internet if we don't know, uh, building answers from that, but also being able to give inputs ourselves to this uh, production of solutions to kind of guide the AI into uh, giving solutions that are not only the best but also efficient, maybe shorter, or give more in-depth explanations that don't kind of guide the user into a solution that isn't the most optimal. Um, and yeah, that should be it for me. So thank you so much, and I'll see you next week.